In compound interest scenarios, the factors or the important pieces of information include the principal, which again is the amount borrowed or deposited. It is the money that starts up the transaction. In these considerations, we will also include something called the future amount, which is the amount after the interest is applied. It's not the interest, nor is it the principal, but it is the combination of the two at the end of the transaction. So the future amount is how much money you have at the end of the transaction when interest has already been applied. And then there are two other factors that we need to consider. There is a rate of interest. However, because of the structure of compound interest, we have to consider that rate of interest per period. And then we also have to, rather than think about time in terms of years, we have to think about time in terms of the number of periods that transpire for this transaction. And it's also important to note, or always important to note, that periods are based on how the interest is compounded, whether it be compounded quarterly, compounded monthly, compounded semi-annually. And this will come into bear in calculating R and N, and also in solving for P or A. So if we are calculating A, which is the future amount, the amount after the interest has been applied, is essentially the calculation you have to do when you are being asked to work out how much money you will have in the future given what you've deposited right now or in the present. And the formula for that is A is equal to P, which is the principal, multiplied by 1, the number 1, plus R raised to the power N. For example, if Tim deposits $2,500 in an account that pays 4.8% yearly interest compounded quarterly, how much will he have on the account in 2 years? And this is asking how much will he have in the future given what he's deposited today. Therefore, we are solving for A. A is equal to P multiplied by 1 plus R raised to the power N. Now it helps to establish what each of our values are in a particular scenario. So P in this situation is equal to the amount of money he deposits, $2,500. 1 is 1. R is the interest rate per period, and the periods are quarters since the interest is compounded quarterly. So that's 4.8 over 100 divided by 4, which is 0.012. Just remember that we are always writing R as a decimal. And N, the number of periods, is 2 years, but we are concerned with the periods, which are quarters. There are 4 quarters each year, which makes it 8 periods. Therefore, for our solution, we must input 2,500 multiplied by 1 plus 0.012 raised to the power 8. When you input that in your calculator, you should get $2,750.33. We can also be asked to solve for P, which is the principal. And essentially this would be a question or consideration where you are seeking to work out how much you need to deposit now in order to earn some given future amount. So you know what your goal is, and you know what interest is being offered, and the question is, well, what do I need to put down now so that I can have, let's say, $5,000 on the bank in 10 years. And to solve those questions, we use the formula again. This time we are expressing it in terms of P. P equals A divided by 1 plus R raised to the power N. For example, Amy wants to have $4,000 for her birthday trip to Hawaii in 3 years' time. Her bank pays 6% interest per annum, compounded monthly. How much must Amy deposit today in order to reach her goal? If we want to know how much she must deposit today, we're trying to solve for P. P is A divided by 1 plus R raised to the power N. As always, it helps to establish what we are trying to solve for. A is the future amount that she is trying to reach, $4,000. She wants to have $4,000 in 3 years' time, so the future amount is $4,000. R, interest rate per period, is her interest is 6% for the year, compounded monthly. So we divide by 12 months in a year, 0.005. And then N, 3 years is the length of time for the transaction, but the periods, N is the number of periods. The periods are months, and there are 12 months in each year, so that's 36 periods in all. And then we can simply replace the letters in our formula with the numbers that apply to this particular scenario. 4,000 divided by 1 plus 0.005 raised to the power 36. When you input that into your calculator, 4,000 divided by open brackets 1 plus 0.005 close brackets raised to the power of 36, you should get $3,342.58 as the amount of money she needs to deposit currently, so that in 3 years' time she'll have $4,000 on her bank account and be able to enjoy her trip.